So in this video, we're going to start chapter 2, and we are going to talk specifically about reasoning and logic. So the first thing we need to do is define a few things, a few terms. So one is logic, and logic is just a method of reasoning. But when you are reasoning with logic, everything has to be defined in a way that's going to leave no doubt or vagueness in meaning. So you're going to have a statement, which is a sentence that is either true or false. It cannot be both. So here are a few statements. So we've got this one: dolphins swim. Scooby-Doo is a cartoon character. 4 plus 5 is 200. Spartanburg is in South Dakota. And then here is a math statement. Okay, so all of these could be decided to be true or false. Here's some that are not actual statements. So you've got 3 plus 8, or watch out. Okay, so those aren't true or false. She has blue eyes. Well, what makes this vague is I don't know who she is. Here is a math statement, but it's got a Y in it, or what are you doing? So all of those are not statements. Okay. Could we make any of these into statements? Yeah, we could make some into statements. We could say that equals, we could say that equals maybe 25. Okay, well then that's a statement. It's false. Watch out. Here's one. She has blue eyes. How about Susie has blue eyes? So once you state who it is, then we know that it is a statement. If I could change that Y to 10 minus 5 is 12. Okay, so those we could make those into actual statements. Okay, so now let's talk about negations. So when you have a statement, we're going to let the statement be P. Okay, it's going to, because math people, we have to make everything a letter. So we've got a statement, and most people in logic use P's and Q's. We don't use an S for statement. So P. It's possible to create the negation of P. So something that is the opposite. So the negation of P is represented by that little squiggle and a P. And that means not P. So if a statement is true, like 3 plus 5 equals 8, then its negation would be false. Okay? If a statement is false, then its negation is true. So now let's talk about truth tables. Truth tables are just a symbolic system that's going to help us when we study logic. So we have P, which is our statement, right? So there's our statement, and this is our not P. So if whatever our statement is true, then that means the not P is going to be false. And then if our statement is false, then when we say not P and give the negation of it, that's going to be true. So a statement and its negation must have opposite truth values in all possible cases. Okay, so here is some examples of a negation. 3 plus 5 is not equal 7 to 7, so which is a true statement, right? The negation would be 3 plus 5 equals 7. Notice that is a false statement. Or 15 divided by 5 is 3. The negation would be 15 divided by 5 is not 3. Or Susie's eyes are brown. The negation is Susie's eyes are not brown. I sort of like this. This is the labels for a door. So the entrance, not an exit. The exit, not an entrance. Thought that was pretty funny. Okay, so let's talk about some more words. So one is called a qualifier, and that is a word that shows the amount of something. So this is a lot more complicated to negate, okay? So universal refers to everything in a sense. So all people are hungry, or everybody failed the math test, or nobody likes pumpkins. Okay. Essential refers to one or more or possibly all of the set. So that would be some. Some people don't like pumpkins, or at least one person likes lattes or something. Okay. So here are some statements and their negation. Okay. So anytime the statement says all people like pumpkin spice, the negation would be, well, some people do not like pumpkin spice. And if you say, well, some people do not like pumpkin spice, you would negate it by saying, all people like pumpkin spice. Here's another one. Some people, some people love pizza. The opposite of some people love pizza is no people love pizza. Or if you said no people love pizza, the negation would be some people love pizza. So this is a sort of a shorthand. So all, to negate it, you do some or not. And if you do some or not, then you go back to all. Or some, you negate it by saying none. And if you say none, you negate it by saying some. So let's practice. Okay. So here are some examples. So here's my statement. All people are brilliant. So if we look up here, all. So the negation is some are not. So some people, some are not brilliant. If you say some students do not take Math 211, you would negate it by saying all students may take Math 211. Some dogs bark. Notice this doesn't have a not in it. It's just some. Some dogs bark constantly. You would negate it by saying no dogs bark constantly. Or no students text in Miss Kitt's class. You would negate it by saying, well, some students text in Miss Kitt's class. Of course, those are my really bad students. All right, so let's practice negating this one. All PB&J sandwiches are delicious. So remember, the opposite of all is some are not, right? So we'll say some PB&J are not delicious. Some teachers give extra credit points. Now notice there's not a not in there. So when it's not a not, then you would say the negation would be no. So some teachers give extra credit points. No teachers give extra credit points. Some people do not like math. So the negation would be all people like math, right? Because it was some do not. The opposite is all, okay? No students like English. The opposite is all students, or some students like English. No students like English. Opposite is some like English. Some birds don't chirp. This one's tricky. This one is a sort of a trap. I'll write up there. Trap. Okay. So some birds do not. See the trap? That don't. So we're talking some do not. So you negate that with all. All birds chirp. Okay. Some girls like football. So the opposite of some is no. No girls like football. No boys like green beans. Well, some boys like green beans. All mathematicians are beautiful. Well, some mathematicians are not beautiful. Okay, so there's some practicing for negating. Okay, but using logic, I don't see why in the world we need truth tables, Miss Kitts. Okay, well, we need to learn truth tables so that we can get figuring out if we have valid reasoning or not. If George Washington was assassinated, then he's dead. Therefore, if he's dead, he was assassinated. Okay, so that was from last chapter, and we said no, that's not. It is not. That's not valid. So, not valid. Okay. Um, if you use heroin, then you first use marijuana. Therefore, if you use marijuana, then you will use heroin. Okay, so this actually is not valid, but this is an emotional subject. Some people, um, they have a lot of emotions tied to this. If you use marijuana, then you're going to use heroin. Maybe someone who has been addicted to stuff, and they want to make sure nobody gets on heroin, so they're going to say it's valid because they're letting their emotions get into it instead of looking at just the logic. Okay. So both see the second one, both people see the second as valid because of the emotional appeal of the words. Truth tables translate these words into symbols so you can determine the logic of it, and that takes the emotions out of it. Okay. So here's some compound statements. Okay, so compound statements is formed by combining two or more statements with words like and or. So and is represented by that. I call that a caret. It's represented by a caret. It's called a conjunction. Okay, so I call this symbol a caret, but the and is actually called a conjunction. The or is represented by that the right there, and this is called a disjunction. Okay, so who would come up with all of this? The doctor of truth, Augustus de Morgan, was one of the main people that came up with these truth tables. So we're just going to do some basic truth tables. Um, so, so our truth tables. Oops, excuse me. So our truth tables, let's think of two two statements, a compound statement. I got ice cream and I got sprinkles. Okay. So we've got the and. So the P is ice cream, and then Q is sprinkles. Okay. So if this is true, we're trying to say and. So if I did get ice cream and I did get sprinkles, then the statement I got ice cream and sprinkles would be true because I did. I got both of them. Okay. But if I got ice cream but I didn't get sprinkles, so that's true and that's false. I got ice cream but I did not get sprinkles, then it's false when you say I got ice cream and sprinkles because I didn't get both of them. If I did not get, if it's false that I got ice cream, so if I didn't get ice cream, but I got sprinkles, it would still be false because you said I got ice cream and sprinkles. And if I didn't get either, I didn't get ice cream and I didn't get sprinkles, then that would be false as well. Okay, so notice the only one that is true is the very first one. Let's see if I want to highlight that. Okay, so this is the only one that is true, and it's only when both of them are true. That's called a conjugation. So and. Okay, so let's talk about or. So with my or, we're going to do ice cream and sprinkles again. Okay, so I got ice cream or sprinkles, and when I got both of them, that it's going to be true. I've got ice cream or I got sprinkles. If you got both, that's okay. If I got ice cream or sprinkles and I got my ice cream, but I didn't get the sprinkles, that's also true. I got ice cream or sprinkles, and let's say I did not get ice cream, but I did get sprinkles. That's going to be true. So the only one that's false is if I didn't get either. If I didn't get ice cream and I didn't get sprinkles, then it's false that I got ice cream or sprinkles. So in this case, you only have one false, and that's when they're both false. Okay, so when it's an and, you only have one true, and it's when they're all true. When it's an or, you only have one false, and it's when they're all false. Okay, so I'm stressing that because these are things you need to memorize for your test. Okay, all right, so here's some. Let's do some more basic truth tables. Notice we have our P. I have a statement, and it's either true or false. Okay, so the negation of those would then be the opposite, right? So if this one is true, then the negation is false. If this is false, the negation is true. Now we're going to negate the negation. So I'm going to take the false and I'm going to do the opposite of that. I'll take true and do the opposite of that. So I go back to true and false. Okay, so we're going to do the same thing. We have our statement P, and we've got true and false. The negation is just what we did above. So we have false and then true. But now, notice this is our or, right? So or, remember, or is the one that is false, and it's only false if they're all false. So are both of these guys false? Nope. Both of these guys false? Nope. So that means both of those are true. Okay. So this one is and. So this is my and. And remember, and is the true, where you just have one true. And that only happens when you have both of them are true. Pardon me.